All right, welcome, ladies and gentlemen. My name is Brian McLogan, and this is week number 43, Open Q&A, and I am very excited to answer some questions that you guys have submitted this week, and also to kind of cover our weekly topic here of me getting my life back. And it's kind of more of a little bit of a joke, but it's actually in all seriousness because I think we can all agree that this year has been completely, not to use the word unprecedented, but definitely been something that we have all had to adapt to. And, the last couple of years, I've really kind of mainly focused on teaching pre-calculus, and I was, ready, gearing up for again another year of that. And then obviously besides the COVID, the pandemic, teaching online, this year, I have not been teaching without a planning period, and I've actually taken up a geometry honors, geometry standard, and an algebra 2 class in addition to my pre-calculus classes. So it has been a very, very, very busy, stressful year on top of just the teaching online, the COVID, and everything like that. So, but it's just one of those things, like you just adapt, and you get through the year and it's like, we got to do what we got to do. And that's what I, kind of wanted to make sure that, we could provide our, my students with the best kind of, education we could. Right. And just be like, hey, I'll be there. I can, teach this content. And I just want to make sure that the students have the, opportunity to be successful, regardless of this kind of situation that's going outside of the classroom. Well, thankfully, since we've been back in school, probably for, a couple weeks now, that the numbers have looked up pretty good and they've been able to hire some additional teachers. So therefore, I will get my planning period back. And originally, at first, when they told me about that, I'm like, hey, you know what? I'm kind of cool. Like it's working out. All right. But since I've been kind of now going back into the classroom, I'm like, I cannot believe how crazy I was trying to teach all those classes because it is, I cannot wait to have an extra planning period just to be able to respond to emails during the day, just to maybe plan a little bit for the next class period. Because after this point, I mean, it is just teach all day long. And then it's after school is the only time that I'm able to, really I just try to do my attendance. And then you got, parent conferences or whatever else may be happening. I got to head home and get my kids. And yeah, it's just like this constant just circle. Like you just never have any time. I am proud of myself. The one thing I did, one thing at the beginning of this year that I did not want to let go of was the weekly live streams. And you can see that, I started listing the weeks, because I've been going live for, over a year now, but I just haven't been consistent. And so the start of 2020, I really wanted to be consistent, going live every single Sunday. And so that is one thing that I have been consistent on. And even though my life has been pretty crazy, just like everybody else, though, right? I'm not any special. There's nothing special about what I'm going through compared to everybody else. But the one thing that, I did want to make sure that I followed through on was being able to go live and answer your guys' questions. And so that's really kind of one of the things I wanted to let you guys know of, is, we look into things that we've all adapted, throughout this year, and we've all made sacrifices. And obviously this year has been a lot more difficult for others, based on their certain circumstances. But, I think the one thing also to kind of realize is, after we adapt and we adjust, there is some little things that, to look forward to. And the little 45 minutes, giving that back throughout the day, you wouldn't think that would be a very, big accomplishment or big something. But to me, this is huge. And that's why once I got this news, I'm like, I am so excited just to have that 45 minutes to exhale, stare at the wall, and not talk for 45 minutes, just to reply to an email. I'm just excited. And so it's something I'm definitely looking forward to. And also it allows me to do some other things during the class period, that I'm just so exhausted throughout the day because I don't have that time to recharge. So I did want to let you guys know of a couple things that are going to be happening in the next couple weeks, because I know some students are going to be taking some exams. So I wanted to let you guys know, if you are taking a pre-calculus exam, I do have some opportunities that are going to be coming up for you guys. I do have some reviews that I have created, as well as the ones that I've worked in the past, that I am kind of putting together as far as a review packet, because it has been a while since we have prepped and prepared for reviews or for semester as well as final exams. And I know some of you might already be taking exams, or you're not going to take exams in for a while. So it's not going to be the right match for everybody. But if that is something that you are looking into taking an exam within the next couple of weeks, this might be something that you're interested in. It is primarily, or it is only just for the pre-calculus students, because those are the students that I'm taking, that are currently taking my online class. So this is one of those things that they are working through. And it's also something that I'm going to be providing to my members. We just did a little live stream here before this live stream to kind of get a little private chat, because I am starting to get a little worried. I'm not at the stage now, but I am starting to get a little worried that I'm not going to be able to answer as many questions on the open Q&A just for regarding my time period. I mean, I think today I went through 43 questions, just to kind of review. And out of those 43 questions, I whittled them down to 16. And not all the questions that I took away were just ones that, not all the questions I would say that out of those 16, some of them students asked multiple questions. I'm not able to address multiple questions. A lot of students asked questions that were very vague, and I didn't really understand what they were actually wanting me to do or help them with. And then also students asked multiple word problems and stuff. And, you guys can see, as far as going through 43 questions and trying to prepare you guys for a live stream, I got to be able to make a decision rather quickly as far as what I can do and help you guys out with. So I do apologize if I didn't get to your question tonight. But just remember, you guys can always go back and look at my live streams, and you can see that all of my live streams have now been timestamped. So therefore, you can see what questions I have asked for each live stream. If you're not able to make the live stream, or you always want to go back and see a replay, you can see the timestamps down below, and that will help you kind of see what types of questions that I go ahead and answer. So that's what we're going to cover tonight. I have 16 questions, a couple of good ones that... again, some of the questions I don't go through. I don't really like doing this word problem, but this one was rather just kind of looking at this angle. So they gave me a figure, and I was at least able to kind of go through it. So either way, without further ado, guys, we'll go ahead and get started right into the math for tonight. And then again, just a reminder, if you are taking a semester exam, my next 2 live streams will be dedicated to kind of talking about semester exam, or talking about taking exams and prep. And then I'll also have an opportunity for those pre-calc students that are looking for a little bit more extra help for you guys. So, all right. Well, thank you so much. Where is my thing? There we go. Whoa, a lot of you guys. All right. Raphael, Prince, I post videos because it's cool. Jada, Shanuk, Diane, Melinda, Eugene, Fernando, Bollywood, Robert, thank you so much. And Owen, thank you so much, guys, for joining in. Yana, you are very welcome. I am very happy to be able to help you guys out. If you guys do have some additional questions after I am done with these questions. So if this is the first time you've been on my stream, just let me kind of go over a little bit of housekeeping, just to let you guys know. These are all questions that have been submitted to me using my Google form. So in the description of this video, you will see a Google form that you can go ahead and submit your questions to. In addition to that Google form, if you are looking for submitting some questions or helping some students with their math, I also have a Discord server that you can go ahead and connect with as well. There you can go ahead and post your questions, as well as respond to students and help them with their own. So I only go live answering your questions every Sunday at 9 p.m. Eastern Standard Time. And so therefore you can go ahead and submit your questions there, and I will do my best to be able to help you guys out. All right. And then, but anyways, so when I get through this, I'll try to maybe, I will sometimes take some breaks as I'm going through these questions. But a lot of times, guys, I just try to get through this math as quickly as I can. And then I always add back into the chat and check in with you guys. So is math just about practice? Yeah, well, I mean, it depends. depends on what you mean by is just what is just math. It's not always about practice, but we can always get me off tangent. All right, that's a good old like teacher trick to get your teacher off topic, and they can just start talking for the whole time. But I'm gonna go and get focused on getting these problems and covering these, and then we'll go from there. So let me go ahead and change my. Let's do red. All right. Yeah, unfortunately I don't have an algebra 1. But that is one thing I'm looking into doing for you on that. But unfortunately at this point I don't have anything additional. All right. I can't remember if this was, I guess, Kanye was asking as far as how to solve this inequality. I think there's a couple different ideas that we want to look into as far as like when you're looking into like graphing this equation. We need to kind of understand like where it could kind of change, right? Where it can kind of change from positive to negative. So when I look into like graphing this, y equals x plus 6 all over x squared minus 5x minus 24. All right. So there's a couple things. Remember, the x-intercept is going to be when the when the numerator is equal to 0. Okay, so therefore that's going to be x equals negative 6. And then we can say the vertical asymptotes is when the denominator is equal to 0. Minus 24 is equal to 0. So therefore we can say what? X minus 8 and x plus 3 equals 0. So therefore x equals 8 and x equals negative 3. Okay, so let's go ahead and graph this function. And what I'm going to do is I'm just going to kind of show you what I would do from here. So we have negative 6. 1, 2, 3, 4, 5, 6. We have at not negative 8, that's at negative 3. We have negative 3, 1, 2, 3 as a vertical asymptote. And then we have at 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for each one of these kind of like intervals, we got to be able to determine, is this graph going to be positive or negative, right? These are going to be kind of like, if you look at these like on a number line, these are going to be kind of your values. The graph is either going to be above or below, right? So, you know, at negative 8, it's going to be, you know, either below or above, right? Because it's obviously crossing the x-axis. And then this, the asymptotes, it's either going to be approaching here positive or negative. So we got to be able to find these intervals. Is it positive or negative? So what I would do is I would just plug in, like, let's just pick some numbers like negative 7. Let's pick negative 5. Let's pick 0. And then let's pick 9. Okay. Now what you're going to do is you're going to plug these values in. And what we're going to do is we're going to look at, is that going to make the number positive or negative? So when you plug in negative 7, right, and you can just use your calculator, plug in negative 7, and you're going to get a negative over a positive, which will be a negative. When you plug in negative 5, you're going to get a positive over a positive, which will be a positive. When you plug in 0, you're going to get a negative. And when you plug in like 9, you get a positive over another positive, which is positive. So therefore, it looks like we kind of have these intervals where the graph is going to be positive. Looks like it's going to be from negative 6 to negative 3. And then from 9 to looks like infinity. So it looks like that is going to be the interval when the graph is going to be greater than 0. Okay, and again, all I'm simply doing is plugging in these values, or any point. It doesn't really matter what the point is on those intervals, plugging them in to be able to determine that inequality. And again, it's been a while since I've done the inequalities, so hopefully at least that kind of made sense for you. I don't like to do a lot of equations or a lot of problems that it hasn't done in a while, but hopefully that makes sense. I'm not really sure what the student was asking for on this one. Typically, this is a question that I wouldn't really address, but I guess they caught me early in a good mood, so I was like, all right, well, I'll just add it. So this is from Asa. They're just asking for the triangle angle sum theorem. Well, the triangle angle sum theorem basically just says that all the angles in a triangle, 1, 2, 3, they add up to 180 degrees. So we could say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And so a lot of times, sometimes we will express the angles as like an expression, or we'll be given one of those values. And then basically you can see we just have an equation. So you go ahead and solve. The next question was provided by Self-Made Ruse. So this one says, if p of -2 equals 0, what will the remainder be if I divide p of x by x plus 2? So I thought this was pretty interesting because, you know, x plus 2, that is the factor, right? So if x plus 2 is a factor, then we could say x plus 2 equals 0 and say x equals -2 is a potential 0, right? Now, again, we don't know if it's a 0 or not. We either need to apply synthetic division or to plug the value in and check the remainder theorem, or, you know, and the remainder theorem says whenever you plug in that value, like k, whatever you get, that's going to be the remainder. Well, since this is going to be a remainder 0, like we can see that would be the remainder. So, I mean, the answer is right there. You don't really need to do any work in this case. If I divide, because it's already saying, like, if that's the factor, if you already know p of -2 is equal to 0, well, that's going to be the root 0, right? I mean, you're already, that's it. That's all you need to do. That is your factor. So you could obviously, I'm not really sure what the point of the question really would have been. I guess maybe just understanding the relationship between the remainder theorem and the factor might have been the point of this kind of question. But, you know, typically we might say, like, hey, if x plus 2 is a factor, you know, what would the remainder be? And then you could plug in p of -2 and be able to figure that out, right? But here they already tell you what the remainder is. So it's like, all right, well, the answer is 0 then. So kind of an odd question, but I'll take it because there's not a lot of work there. All right, so the next question, I do have a calculator, but I'm not going to use my calculator. I'm just going to kind of set up the expressions for you. So it says this 1.2 meter girl spots a balloon moving with the wind in a horizontal line, okay, at a height of 80.12. Okay, so what we can easily do is just go ahead and say, all right, so let's do 88.2 and let's just minus 1.2, right? So that's going to equal 887 meters, right? Okay, so that's going to be the height of my two triangles. So therefore, we can just kind of forget about that. And then, so basically what we're looking for is we're looking for these two horizontal distances. So I'm going to call this x1 and I'm going to call this x2. All right. And basically what we're trying to do is after some time angle, find the distance traveled. So we're looking for this distance. Well, that distance is going to be x2 minus x1, right? So now we basically just need to create an equation to be able to understand these two distances. And you can see here we have the height and we have the angle. So we can be able to find x2. So we could say, let's see, so we have opposite over adjacent, right? So I can say, all right, so if I want to find this, I can say the tangent of 30 degrees, which is this degree angle right here, tangent of 30 degrees is equal to 87 over x2. And then I can also say that the tangent of 60 degrees is going to be 87 over x1. And again, to find this distance, right, to find the distance between these two, all you simply need to do is do x2 minus x1. So I got to be able to solve for x2 as well as solve for x1. So what you'll do is you multiply by x2 on both sides, and therefore you get x2 is equal to the tangent of 30 of 87, and then do solve here. I'll just divide by the tangent of 30. Sorry, my handwriting's a little off there. So therefore, I will get a x2 is equal to 87 over the tangent of 30. And then you'll subtract that from x1. And again, hopefully you see it's the exact same process over here. It's just going to be a little bit different. You know, you're going to multiply x1 and then divide by tangent of 60. So therefore, we can just kind of skip down to x1 is going to equal an 87 divided by the tangent of 60. And there you go. Just go ahead and subtract. D equals x2 minus x1. Okay, so you'd want to go ahead and use your calculator. Make sure you have degree mode set in the calculator, and then make sure you're using the non-rounded answers for you out there. All right, the next question, the student gave me a lot of equations, and typically I do not solve a lot of equations or a lot of problems, right? I mean, typically, guys, I want to get to as many students' questions as possible. But I kind of liked what the students, this question, I think they even brought more than 3. I think they gave me like 6 or something like that. And I was like, all right, well, I'll at least do 3 to be able to help you out. But just because I like the variety here of answering different types of questions. So the first one was the piecewise function, and I think this is kind of helpful. A lot of students have trouble with piecewise functions, so I thought this would be beneficial. And then we have the quadratic, which is kind of beneficial as well. And then we have another quadratic, but it's in a intercept form, or a factor form, and I thought that'd be kind of nice. All right, so in this case, remember a piecewise function, guys, all it is a combination of 2 functions, okay? And we actually just kind of recently covered this in my Algebra 2 class. So basically, I'll kind of teach it the way that I taught them. And the first thing I would recommend doing is forget about the domain restrictions. Just graph the function. So I have negative 2x minus 4. So remember, this is a linear equation, right? This is y equals a negative 2x minus 4. Well, let's graph that. So we have a y-intercept at negative 4. 1, 2, 3, 4. And then we have a slope, which is negative 2. So again, remember, this negative slope means the graph is going to be decreasing. So therefore, I'm going to go down 2 to the right 1, or you can go up 2 to the left 1, okay? But either way, this graph is going to be looking like from there or like there, right? So that's what the graph looks like. And then we have our other graph, which is at y equals 3, right? So that's your graph y equals 3, right? So, and that's just going to be a horizontal line. So we go up 1, 2, 3. Let me actually, oops, not that. Oh, come on. It's annoying. All right, so we'll just kind of go from there. Don't know why it's doing that to me. Okay. So here's your 2 functions graphed on the same axis or on the same coordinate plane. And obviously, guys, this is not a piecewise. This is not a function because you can see it doesn't pass the vertical line test, right? It's not a function. So therefore, that's why we have to apply these domain restrictions. So it says only graph negative 2x minus 4 for x values that are less than or equal to 1. So we can say, well, here's 1. Oh, I should have done 1. Was it negative 1 or 1? Dang it. I don't know. I wrote it as 1, so I kind of did the wrong graph. So oops. All right, so it says for only x values that are greater than 1. So that's going to be from here going all the way to the right. That means everything else I'm going to erase. Only x values that are greater than 1. Everything else is not within the domain restriction. Now again, that's, oh crap. Let's undo. There you go. This graph was for x values less than or equal to 1. So actually, it's everything to the right of 1. So it's actually going to be all x values less than or equal to 1. So that's going to be here going this way. So everything to the right of 1, right? Because here's where 1 is. So everything to the right 1 is not in the domain restriction. Okay, so it's only going to the left of 1. Then the next graph is for all x values greater than or equal to 1. So that's going to be here at 1. And then all going to. And again, I'm using the open circle because obviously at 1, it's not included. So everything else is going to get deleted here. And you can see that's what the graph looked like. So when you look at the graph with the domain restrictions, you can see this is actually a function. Okay. The next one is going to be a quadratic with our asymptotes. So what we're going to do in this case, guys, is again, we need to understand our parent function, which is the quadratic, right? So that's y equals x squared. And then we just need to understand our transformations. So we're going to basically be taking this graph, which is our parent function. We're going to reflect it about the x-axis. When we multiply by a negative outside the function, that's going to be a reflection about the x-axis. Subtracting a 4 inside the function is going to shift the graph 4 units to the right. And adding outside of the function is going to shift the graph 2 units up. So I'm going to go 4 units to the right, 1, 2, 3, 4, and then up 2 units. So that's going to be my new vertex. And I think it's always important to first find the new vertex. I'm just going to sketch it, so don't be analyzing my x-intercepts, okay? Because that's not designed to be perfect. This graph they're not going to be stretched or compressed at all, so they should look exactly the same. But obviously, the way that I'm graphing them, they don't look that way. But you can see it's the exact same graph, just shifted to the right for up to, and then reflected about the x-axis, okay? And again, I just like to do the sketch. That's the way I like to have my problems done. The last example, I really like this problem because we don't know the transformations. The only thing we know right now is the factors. And if you remember, if we know the factors, we can find the zeros, right? I kind of talked about that over here. You have the potential zero, right? And that's going to be like the x-intercept. So right now, I know that I have a 0 at -5, 1, 2, 3, 4, 5, and at -1. We don't know what the vertex is. We could find the vertex, but we're just trying to sketch the graph here. We have a 2 on the outside, which would be a vertical stretch of 2. So that would make this quadratic a little bit skinnier than a typical quadratic. Now, I think the main important thing, though, is if you were to multiply this out, you would get a x squared something, right? I mean, you could multiply it out, but let's say you didn't know how to multiply it out. Hopefully, you at least know when you multiply x times x, you're going to get an x squared. And then you multiply by 2, and that's a positive x squared. And so a positive 2x squared is going to have a graph that's going to open up, meaning it's going to have an absolute minimum. I don't know where that absolute minimum is. It's probably going to be somewhere down here, but all I know is this graph is going to go open up to the left and to the right. And that is because I know that is a positive 2x squared, and that's the behavior. Because when it's negative, it's going to open down. So you can kind of see the difference here between those two. So I thought that was hopefully helpful for you guys. All right, the next question was identifying the limit as x approaches infinity. And so in this case, when you have a rational function, typically what we want to do is be able to identify the growth of the function. And when you have a rational function with polynomials in the numerator and denominator, the way that you want to evaluate the limit is just look for the asymptotes. Look for the horizontal asymptote, And, because there's 3 things you want to look for. Or I'm sorry, 3 scenarios. And again, this works for rational functions when you have a polynomial in the numerator, polynomial in the denominator. Once we start throwing in different functions in the numerator and denominator, or radicals, like that kind of changes, so we'll have to adjust. But for when you have polynomials in the numerator and denominator, we're just looking for the horizontal asymptotes. So therefore, we need to understand the horizontal asymptote test. And when n, which is our degree in our numerator, is less than a degree in the denominator, then our horizontal asymptote is y equals 0. So this limit, as x approaches infinity, my denominator is going to be growing faster than my numerator. And therefore, it's going to have a horizontal asymptote at 0. That means the graph is going to be approaching 0 as it keeps on going to the right. When my n is equal to my denominator, like let's pretend that was a 2, then my horizontal asymptote would be a over b. So in that case, they would be like y equals 2 over 4. And last one is when my degree in my denominator is less or greater than degree in my numerator, there is no horizontal asymptote. So therefore, you want to look at the oblique or look at the slant asymptote. So that is something you want to go ahead and take a look at. And basically what you'd be able to do is just go and identify the slant asymptote. Is it going to infinity or is it going to negative infinity? Or is it a hole and it doesn't have any behavior from there? So those are some things to kind of look at when you have a rational function. Question number 7 says the student was asking, how do you evaluate 11 pi over 3? So next thing you want to do, guys, when you're doing the evaluating your trigonometric functions is, first of all, understand that when you go hopefully you guys understand that halfway around a circle is 2 pi, right? Which in terms of thirds is going to be equal to 6 pi over 3. So if I go all the way around a circle, right, that I'm back to where I started, okay? So the important is when you have an angle that's larger than 2 pi, we don't need to include that extra revolution. So, the sine of 11 pi over 3 is equal to the sine of 6 pi over 3 plus 5 pi over 3, right? 6 pi over 3 takes us right back to where we started. And then we go an extra 5 pi over 3. So we don't really need to worry about the 6 pi over 3. We just need to figure out, well, what is the sign of 5 pi over 3? All right, so then let's go back to our unit circle here and say, all right, so we need to basically break this up into thirds, right? So we know halfway around a circle is pi. So if we break that up into thirds, so this is 1/3, 2/3, 3/3, right? So that's 3 pi over 3. And let's break this one up into thirds. So this would be 4/3 and then 5/3. So we need to be able to figure out what that point is on the unit circle. And hopefully you know on the unit circle you have the first quadrant at least known. And the first quadrant here, we recognize this reference angle to be pi over 3. So I say, all right, well, pi over 3 is going to be right there. And that coordinate point for pi over 3 in the first quadrant is going to be 1/2 comma square root of 3 over 2. Okay, but you can see we're not in the first quadrant. We are in the fourth quadrant. So therefore, the y-coordinate is going to be negative. So this answer is going to be a negative square root of 3 over 2. Because again, the point 5 pi over 3 takes us to the fourth quadrant. So even though we're going to use the same coordinate point, 1/2 comma square root of 3 over 2, remember sine represents the y-coordinate for a point on the unit circle. And again, the angle lies in the third quadrant, or fourth quadrant, I'm sorry. So therefore, that's why we got the negative value there. So let me try to sneak that in a little bit better. So equals a negative square root of 3 over 2. All right. The next question is convert theta to 2 pi, or I guess it's an a. So 2a pi divided by 3 from radians to degrees form, where a is a natural number. And then find the smallest value of a if theta lies in the second quadrant. Find this if a lies in the second quadrant. Okay, well, first of all, if we want to convert from degrees to radians, all we simply need to do is multiply by our conversion ratio, which is going to be a 180 degrees over pi. So therefore, if I have this angle, so let's say 2a pi over 3, I'm just going to multiply by 180 degrees over pi. So what that does is that divides out our pi's, and we can divide 3 into 180. That's going to give me a 60. And then 2 times 60 degrees is going to be 120 degrees A. Okay. So now we have our angle in degrees, 120 degrees A. And then find the smallest value of A if theta lies in the second quadrant. Well, we know in the second quadrant, right, it has to be between 180 degrees and 90 degrees. So I would have to say that, 9 degrees. So this is going to have to be one less 180 degrees A, but it has to be less than 180 degrees. Okay, so therefore I would just divide by 120 degrees, and I believe I'm doing this right. I don't know. And therefore A has to be less than or equal to, let's see, you can divide a 30 on the top and the bottom. So that'd be a 3/4. And then here you could divide a 6 on the top, which would be a 3/2. Or divide by 60, right? So it'd be 3 and 20. So find the smallest value of A if it lies in the second quadrant. So that'd be 0.75 would be the value of A. At least that I'm figuring that out to be. A would equal 0.75, or 3/4 would be the fraction. All right, question number 9. This student asked multiple questions, so I was able to get to a couple of them. I think I liked B. I think that's what the student was asking, because there was a couple different ways to, I kind of looked at this problem. That's what I kind of liked. So the student said, or the question says, determine the quadratic function in vertex form given the following characteristics. So it says the x-intercepts are -1 and 3, and the range is y is greater than 4. So there's a couple different ways we can address this question. And so we can either address the question by stretching the graph or by shifting the graph. And I thought that was really, I think that's kind of important. So let's kind of see what might work here. So if I have y equals, if I have the x-intercepts, then I know that I can write, those are the zeros, right? So those are the x-intercepts. So I can write these as the factors. So I can say x plus 1 times x minus 3. Now, again, I don't know how low this graph goes. I could multiply that out to give me an x squared. Let's see, that's going to be minus 2x minus 3. Now, I could go ahead and complete the square here. So hopefully x squared minus 2x. You take b divided by 2, which is a negative 1, and square that, give you a positive 1, minus 3, and then minus 1. Oh, well, it already has a y equals negative 4, so that works out. So that's x minus 1, and that would be minus 4. Well, that was easy. So the range is all values that are greater than or equal to 4. Well, cool. That was different. I thought I worked it out differently here. Because if I get y equals x squared minus 2x minus 3, what was I doing? 0. It was, oh, never mind. I did that incorrectly from on there. If I was, what did I do? I like looked at this problem. I did some math before, and I was trying to see if it went through the point. Oh, that would be if it went through the point 0.04. That wouldn't have made sense. Okay, never mind. I take that back. As far as we're not going to want to do the stretch or compression, we would want to look at the vertical shifting down. So actually the way that I originally was going to approach this problem, actually what I did before I went live, actually is not a good approach at all. So what I did is I wrote the intercepts, or negative 1, 3, and therefore I know that these are my factors. And then you just multiply them out, and that's how I got this. And then what I did is I went to go and find it in vertex form, because if it's in vertex form, then all I simply need to do is identify like, I could identify those points. Okay, if those 2 points, then I'd have to be able to see if I could, yeah, you wouldn't want to adjust those there. So I guess that just has the, it'd have to go through those 2 points. Yeah, that'd be a little difficult. So either way, this has the range from y is greater than or equal to 4. So I just had to complete the square to make sure that it matched that. Otherwise, I could use a multiple. I could use a scalar to be able to address that kind of question as well, at least to make sure it satisfies. That's at least the point. I could at least make sure I could try to make it satisfy that restriction. But either way, that hopefully that helped out. How do you do inequalities with two-step equations? How do you do inequalities with two-step equations? I don't really like these questions at all. The vertex would be at 1, 4. Yes, 1, negative 4. So the vertex would be at 1, negative 4. And so the range would be from 4 to infinity since the graph opens up. So I have no idea what the student is asking for in this. So typically I don't really include these, but I don't know. I guess I felt like I should do one. So let's go ahead and make up an example here. Let's equal 10. And then you could also do one like x divided by 2 plus 1 is less than, let's do a negative. And let's do greater than negative 2. Okay, so just remember when you're doing inequalities, guys, we're looking for multiple solutions. You can see in that first example I did, I didn't give you like x equals 5. I gave you an interval. I gave you a range of values because that's the way that inequalities are going to work, right? If I'm not saying x equals 5 or x equals 2, I'm saying x is greater than all of these values, or x is less than or equal to all of these values. So you're going to treat them, as far as the process goes for inequalities, it's the same thing as for equations. How do you do inequality? So it's the exact same steps. You know, you first got to isolate your variable x. So first thing you're going to do is undo addition and subtraction first. So 3x is greater than or equal to 14. And then you're going to, I guess I didn't want to do that. I want to do, let's just make that 8. I just want to make the numbers a little bit nicer. Make that 8. Okay. So therefore, you're going to get to 12, and then you divide by 3 here, and you get x is greater than or equal to 4. So the way that we like to graph these is we like to go and take these on a number line. We say, all right, what are all the values that are going to be greater than or equal to 4? Well, 5, 6, 7, 8. And then we quickly realize, oh, wow, there's actually infinite many numbers that are greater than or equal to 4. So here's 4. Since it's greater than or equal to, that means 4 is going to satisfy that inequality. And it's going to be all values to the right, right? Because here's like 5 and here's like 3. Well, all values to the left of 4 are not going to be greater than or equal to 4. Those are going to be less than or equal to 4. And then all values to the right obviously will be greater than or equal to 4. So you're going to want to set up your equation as an inequality on a number line. Let's go and take a look at this one. And because it's important when you're dealing with inequalities to understand what happens when you multiply or divide by a negative. So here I'll subtract a 1 on both sides. Get negative x over 2 is going to be greater than negative 3. And now here to isolate the x, I'm going to multiply by a negative 1/2. I'm sorry. You're going to multiply by a negative 2, which is going to be the reciprocal here of my negative 1/2. Like since I'm dividing by a 2, I'm going to multiply by a 2. And then since this is a negative, I want to get it to be a positive x, so that's why I'm going to multiply by a negative. So I multiply by a negative on both sides, and I get x is going to be less than a positive 6. And again, the reason why the sign is being flipped is when you multiply or divide by a negative, that's going to flip the sign. And again, you can just go ahead and you can work through some numbers to kind of see why that makes sense. Obviously, I don't have time here for this one to kind of work through it, but you can definitely just do a simple equation like negative x is less than 1. And solve for that to realize plug in numbers and see which one satisfies this to realize that's the same thing as x is greater than 1. Okay. But anyways, let's go ahead and get to 6. This is less than, not less than or equal to. So that's going to be all values that are smaller than 6. That's going to be all values to the left. All right. All right. Question number 11. It says solve the following equations. Can you conclude about the solution? Well, I don't know. Let's go and figure it out. So I have 1 over x minus 1. Plus 1 equals x over x minus 1. So when we're solving an equation like this, what we want to do is get rid of the variable in the denominator. Because we don't want to solve for x when in the denominator. We can't solve for x when it's in the denominator. So the LCD here is going to be x minus 1. So I'm going to multiply everything times x minus 1. When I do that, I get an x minus 1 plus a x minus 1. Oh, I'm sorry. When you multiply x minus 1 times here, the x minus 1s divide out, right? When you multiply this times this, the x minus 1s divide out, so that's going to be left you with a 1. I don't want to write that equal sign. It's going to be confusing. All right, so when I do that, I get a 1, and that's going to be plus x minus 1, right? So when you do x minus 1 times 1, that's x minus 1, equals a x times x minus 1. Apply the illustrative property. I get x equals x squared minus x. And here you guys can see that I realize I have a quadratic. So to solve quadratic, we're going to want to set that equal to 0. Minus 2x. Here you can factor out the x. Okay, use the zero product property. X equals 0 and x equals positive 2. Then you always want to check for extreme solutions. I plug these values back in and it looks like we are good to go. Those are both work. The next equation looks like it was sent from a homework or something, but it says, so all the answers below are integers. The graph shows, I'm not sure how you would type it in. I think this is like the crappy thing with online learning. Obviously this is like a computer screenshot. I don't know. I don't even give students I try to use computer programs similar to this one, and I think it's so frustrating. You can know what you're doing, and if you don't type it in correctly, you get it wrong, and then you're spending time redoing it. It's very annoying. It's very frustrating. So I don't even do these anymore. But I'll try to help you out as best I can. Visha, yes, I do read the comments, but I'm trying to get through this math as much as possible. So therefore, then at the end, I'll always go back and check into the comments. But yes, if you are first joining my questions, guys, these are all pre-submitted questions for me. And you can always submit the questions in my descriptions. In the description of this live stream, you can see where you guys can submit your questions. All right. So the graph of f shows, well, it looks like we have 2 relative maximums, right? So we have relative maximum -1, and it looks like at 1. So those are going to be my 2 maximum values. So I'll say -1 and at 1. and a relative minimum. So these are going to be values that are going to be a minimum. And again, they're a relative minimum because they are minimum values on an interval, right? If you were to like zoom in on those boxes, you could see that they are either the highest point or the lowest point, right? These are your relative maximums. These are your relative minimums. However, you can see this graph continues going up and as well as continues going down. So these are not your absolute relative maximums or minimums. So 0, 2. That's going to be for a total of 4. So, and I guess, the graph shows, I guess maybe you're just supposed to type the number. It's kind of weird. So I guess maybe 2 and 2, right? So I'll just write those in. X equals -1 and 1, and x equals 0 and 2. All right, the next one, the student was asking for evaluate the f of x equals -3 absolute value of x plus 6. So again, guys, just when you're evaluating a function, it doesn't matter if it's an absolute value function, if it's a piecewise function, whatever the function is, whatever this input value is, that's just what you're going to plug in for your input variable. So I have a -3 times a -2 plus 6. So the absolute value of -2, remember absolute value represents the absolute distance away from 0. Doesn't matter if you're going in the positive or the negative direction. We're just looking for that, that absolute distance away from 0, which is going to be 2. So that'd be -3 times 2 plus 6. -3 times 2 is -6. So -6 plus 6 is equal to 0. The next question brought to you by Mahi was how long is the side of the red square and what is the perimeter of the rectangle? So we have a square with an area of 36 centimeters squared is cut into 4 triangles and rearranged to make a rectangle. All right, so we have limited information, right? So immediately what comes to my mind is, all right, if I know the area is 36, like we know the area equals, an area of a circle or a square, I'm sorry, is going to be your side length squared, right? So we could just say, L squared. So if that's 36, then we could say L squared. So we could say L is going to equal 6, right? We'll just call this like L. Now, we know also, since this is a square, then that is going to be 90 degrees. So what that means is that's going to be 45 degrees. Now, it's very important. If I recognize that's 45 degrees, that means that's 45 degrees. That is going to be a special right triangle, right? So because this is a square, I can conclude that's 45 degrees. That's 45 degrees. And this will be 90 degrees. I know it doesn't look 90 degrees there, but you can see that that's going to represent 90 degrees. And if that is 6, then we can say, well, what are the relationships of a 45, 45, 90 triangle? Well, hopefully if you remember from a 45, 45, 90 triangle, that is what we call a special right triangle. And the relationship is the legs are the same, right? Which would make sense, right? The distance from the vertex to the center is going to be the same as the distance from the center to the vertex if it's a square. And the hypotenuse via the Pythagorean theorem would be x squared root of 2. Well, if the relationship to go from leg to hypotenuse is to multiply by the square root of 2, the relationship to go from the hypotenuse to the leg would be to divide by the square root of 2. And then we can simplify this. 6 divided by square root of 2, you can rationalize the denominator. And that'd be 6 square root of 2 over 2, which is equal to 3 square root of 2. Okay. So therefore, that means this length is 3 square root of 2 as well, right? The simplified form. So if I look at this and I say, oh, all right, well, that hypotenuse is 6. That means that's going to be 3 square root of 2. And then this one would be 3 square root of 2, right? So the answer A is going to be 3 square root of 2 quantity squared, which is going to be 9 times 4, which equals 36. And then the next one is what is the perimeter? Well, obviously, if this is a square, the red and the yellow are going to be the same. So we can see that this is going to be, the side lengths are all the same. So how many do we have? 1, 2, 3, 4, 5, 6. So B is going to be 6 times 3 square root of 2, which is equal to 18 square root of 2. And there you go. The next question was brought to you by James. Again, asking multiple questions, but I'm able to at least get to one question for you, James. this one was solve for x. So again, kind of going back into that same format of, rational equation. How do we solve for a rational equation? Get the denominator, get the variable, or get the expression off the denominator. So we need to find the LCD. Since my two denominators have nothing in common, then the LCD is going to be the product of those two. So in this case, it's going to be x plus 1 times 2x minus 1. All right, so when I multiply here times this first expression, the x plus 1s will divide out, leave me with a 3 times 2x minus 1. When I multiply by the second form here, the x minus 1s will divide out, leave me with a 4 times x plus 1. And when I multiply by here, nothing divides out. So that's going to be 2 times a x minus 1 times a 2x minus 1. All right, so let's go ahead and do a little distributive property here. So that's going to give me a 6x minus 3 plus a 4x plus 4 equals, let's see, this is going to give me a 2x squared. Let's see, that'd be a minus x minus 2x. That's a minus 3x plus 1. Then we need to apply distributive property again. Let's clean this up. That becomes a 10x plus 1 equals a 4x squared minus 6x plus 2. Okay, and then obviously you can see this is a quadratic, so I'm going to want to get everything to the same side. 0 equals a 4x squared minus a 16x plus 1. So now I got to see, is this going to be factorable? I'm not seeing if this is factorable for me. 9 times 2, not 9 times 4. I don't know if he was talking to me or not. Yes, Daniel, it is a 45, 45, 90 triangle. But I'm not sure if you're talking about 9 times 4. Oh, it's 9 times 2, right? Yeah, good call. Thank you. You the man. Yeah, 9 times square root of 2 times square root of 2 is 2. So that's 18. Whew. Crazy. Thank you. Good catch. All right, so therefore, since this is not factorable, or at least that I'm not seeing this being factorable, because that'd be 4 times 1. Not seeing that would work. And so it's going to add up to those two values, which not work. So therefore, we can try the Pythagorean theorem. Pythagorean theorem, the quadratic formula. So opposite of b, plus or minus the square root of 16 squared minus 4 times a times c, which is 1, all divided by 2 times a. All right, I do have a calculator, so I do not remember 16 squared. So 16 squared, 256, minus 16 is 240. 16 plus or minus, let's see, 240 divided by 16 divided by 8. Okay, and I'm just going to leave this here. You can obviously go ahead and simplify this radical, but you can see it's not going to be factorable. And the non-simplified answer, I'll just leave it as that. But I am getting to the end of my live stream. So you could obviously just simplify the radical. You could break that down into, see whatever square numbers evenly divide into that and go from there. Ramos says, could you slow down? Yes, I could. I do apologize. I had a lot of questions, and that's kind of why sometimes I'll just kind of talk really fast when I realize like I have so many questions to get done, and I try to get this done all within an hour. So I do apologize if I was kind of going a little bit too quickly here for you. That is on me. That is one of the things that I need to kind of slow down, and maybe that's one of the things why I'm not able to cover cover so much of the problems in one live stream. But hopefully, whatever else I was going through at least made sense, and you can maybe just kind of go back and we'll be able to revise and relook at. But I know a lot of times I kind of talk a little bit quicker. All right, the last one says the height of a closed cylinder is 5 centimeters and its surface area is 100 centimeters squared. Given that the radius is r, show that pi r squared plus 5 pi r minus 50. All right, so we need to remember what the surface area is of a cylinder. So we have the surface area is going to be the base, right? Or sorry, it's going to be 2 times the base. The surface area? Yeah. Plus the sides, right? Or the, like if you were to break this up, you'd have this. This is what we call like the net, right? From in there. Actually, pi squared. 5 centimeters. 15 is x plus 1, not x minus 1. 15 is x plus 1, not x minus 1. Where did I get minus 1? Yeah. I got x plus 1. Oh, dang it. That's what he was talking about. Crap. Let's go ahead and simplify this now real quick. Dang it. Now I got to redo this. Sorry, so now I got to go back. That's what happens when you go too fast. So therefore that's 2 times, let's say, 2x squared. That becomes a negative x, so that's going to be plus x minus 1. And therefore this becomes a 4x squared plus 2x minus 2. And then now when I subtract a 10x and a negative 1, now I get a, that means that's all off. All right, please confirm if this is right. So therefore this is a negative 8x minus 3. And that changes everything now. So now I'm going to be looking into this being factorable, assuming that I did my work. So please go ahead and double check that. So let's go and do 4x and x. And now it's a negative 3. So therefore now I'm looking for the difference here. And 6 and 2. I'm thinking this is going to be with a, so if you did minus 3 and plus 1, that wouldn't work, right? So let's maybe look at a 2x and 2x. And again, that's going to be a negative 6 though. That doesn't seem like it would still work out. 4x plus 2x minus 2. That'd be negative 8x and minus 1, that's a negative 3. So, has everybody seen the factors? 20, can you work? Yeah, you could go ahead and do the AC method. You could do 4 times 3, that's a negative 12, and that's a negative 8. So then what two numbers multiply to give you a negative 12, but add to give you a negative 8? But again, there's no two numbers that multiply to give you a negative 12 and add to give you a negative 8, right? Because if they were going to be negative, then one would have to be positive and one would have to be negative. And so you have a negative 2 and a negative 6, but those don't multiply to give you a negative 12. So therefore, I would have to go and look into the quadratic formula, which is going to be a opposite of b plus or minus the square root of negative 8 squared minus 4 times negative 3, all divided by 2 times a, which is 4. And when you get this one, you're going to get a 64, and let's see, that's going to be a 4 times 4, which is 16 times 3, which is going to be a 3248. So my brain now hurts, it would be 112. I believe. And then which you could 28, 7 times 4, so yeah. So that could be broken down into a 16. So that'd be 8 plus or minus a 4 square root of 7 over 8. Whew. So, and then obviously you could go ahead and simplify, bring out a 4 from there, be 2 plus or minus the square root of 7 over 2. So hopefully that helps you out in regarding that one. All right, but now I'm already past my time, so why I was talking so fast, we now get to that point. All right, so let's go and try to wrap this one up, though. So for the surface area, there's a couple things that we need to talk about. We need to talk about we have double the base plus the side. Okay, so here is your base, and then here is your side, or the wall, basically. All right, so the area of a circle, if you remember the area of a circle, is going to be area equals pi r squared, right? But we have two of them, okay? So we have 2 times pi r squared. And then plus, if you were to unravel this, you can see this is going to be the diameter times the height. Well, the diameter, if you remember, is going to be, let's see, it's going to be 2r, right? That's going to be 2r times pi. So plus be 2r times pi times the height. Now, in this case, they give us the height, which is 5. We just don't know what pi is. Surface area. So, therefore, we have 2 pi r squared plus 2r pi times 5. And then that is going to equal 100. So they're saying the surface area is equal to 100. Well, obviously, we now need to set this equal to 0. So when I subtract 100, I get a 2 pi r squared plus 5 times 2, which is a 10 r pi minus 100. And that's now equal to 0. And again, you could divide a 2 on both sides. And you get 0 equals a pi r squared plus a 5 pi r minus 50, which is exactly what we were looking for. Sorry, that got a little bit lower. So, all right. Whew. Sorry, guys, that was a lot of problems. I'm going to have to figure something out as far as going over so many problems. But thank you so much, guys, for joining in on this live stream. Aiden, it's 11 p.m. It's 10 o'clock here for me. What's your streaming setup? I guess I'll take a little bit of questions. And Robert, you're still here. Awesome. Thank you so much, man, for joining in. Murray, want to know who's asleep is? Iron Man, Randy Cruz. Yeah, exactly. Let me go and see. I'll answer a couple questions because I do appreciate you guys joining me in there. Hey, man, thanks for joining, making videos you post. You are very welcome from Canada. Aiden, good to see you. And yes, I saw organic chemistry tutor or organic tutor, chemistry tutor. Yeah, awesome videos. Are all discontinuous functions piecewise functions? No, you could have a function with a hole in it or an asymptote, and it doesn't have to be a piecewise. And look at you guys getting this chat going now that I go ahead and respond to them. Well, you're very welcome, Jerry. I'm happy to help you guys out. I am so sorry, Randy. I go live every single Sunday at 9 p.m. And again, guys, if you did get to my stream a little bit late and you'd like for me to answer one of your questions, then I got roughly around like 40 questions were submitted this week, and I tried to go through them as quickly as possible. But you can see when I start doing things really quickly, I will start making some mistakes, right? So I'll try to get this balance. I think anywhere between 10 and 15 is going to be kind of like that sweet spot for me. But again, if you're asking for like multiple problems, I'm just not going to be able to get to it. There's like, you can already see, I mean, this took me an hour just to go through these problems. So please try to keep it down to like 1 or 2 questions or 1 or 2 problems. Not asking me to do multiple problems. And the same thing, I basically just do not cover a lot of word problems. It just takes too long. So if I don't have a lot of questions, I'll be happy to look at the word problem. But a lot of times, guys, I just won't be able to get through those. All right. So Dawson says, what did you start teaching? I started teaching in 2007. Yes, Robert, I am here. Thanks for the math tips. You're very welcome. My pre-calc teacher is a good fan. Well, awesome. I'm happy to teach pre-calc. Beds are low-key slept on. Okay. Seems my internet shows it's not showing up very well, but hopefully that's not a problem for you guys on that end. I don't know, William. I would have to work through the problem, and I do not have enough time to go through any more problems, guys. I do apologize. But again, you guys can always submit your questions. I do have my Google form that is in the description. You guys can go right there and I will do my best to answer your questions each and every week at 9 p.m. Yeah, a lot of I also get a lot of questions regarding a lot of calculus. And since I'm not teaching calculus, unless it's something that I immediately see and I have a good feeling of like my explanation, I feel like that's going to be up to point, then I'll cover it. But, some of the calculus stuff, I just need to like refresh my brain. And, I'm just not able to get to all those types of questions for you guys each and every week. All right. It is 9 p.m. for me. Yes, you're better. Well, happy to be able to help you out. Thank you, Jeffrey. Mohammed, I see yours. Exponential equation. I would just, you're going to want to divide by 20 and then take the ln of both sides. So I do not have time to do that question, Mohammed. Sorry about that. But all you're simply going to want to do for that is divide by 20 on both sides and then take the natural log of both sides. And that will take care of the problem for you. All right. Well, guys, what topic are you doing next stream? Good question, Aiden. Thank you for joining. The next two streams are going to be designated for exams. So I will be covering how to prepare for your exam. I think next stream is how to prepare for your final or how to prepare for an exam. And then the stream after that, I'm going to talk about how to like take an exam, like, some testing tips and tricks for you guys on that. So hopefully those will be beneficial for you guys. And then also I'll have some more information for those of you guys that are taking a pre-calculus exam, semester exam, or the final exam. I do have a mini course that I am just kind of basically like all my reviews and my own exams that I am kind of providing for you guys. So I have that kind of like packaged in preparation for you pre-calculus students out there. Isn't the square root of negative 1i? Yes, that is where we call our imaginary unit. Should I major in pure math or applied math? Alexa, it's really up to you. I prefer pure math just because I think that's great. But, obviously applied math, you're probably going to get a little more applications and maybe more job prospects. So it really kind of depends on what you want to go into and really what you're kind of looking out for that degree. Aiden, what if you are in high school? I'm not sure what that means. I teach high school, so these are for semester and final exam. Maybe you're talking to somebody else, but yeah, these are semester exams for my high school. What is the derivative? That is basically going to the measure of the change, the instantaneous change of a curve at any point is kind of a rough definition of a derivative. X equals X is just maybe the identity property. It doesn't seem to mean much other than that. Yeah, I mean, the identity property, identity element is kind of important when you kind of understand, like, it's just kind of going back to like the initial, value. And we kind of use that identity property as well as the identity element to understand a lot with numbers and number sense. And then also when we get into even upper level mathematics, understanding some of those, the grouping and sets, like for rings and groups and stuff like that. All right, what is the date for the pre-calculus exam video? So I will, I'll be talking about that all next week. I'll give you guys I'm doing for my members on my YouTube channel, I'm doing a private, I'm doing like one little study video. And then I'm going over one exam review with my YouTube members. And then I'm going to be doing a private, then I'm going to be doing 2 private live streams for people that are taking pre-calculus as well. But I'll give you guys, I'm not sure of all the details on everything just yet. So I'll plan on covering all that stuff for you guys next week. So you'll definitely hear all about it from me. I'll put it on my, community post. I'll put it in the stories, and I'll put it obviously on my channel. Oh man. All right. Well, I'm not going to be able to get through any more questions, guys. for tonight. But again, just a reminder, guys, that if you have questions for next week, put them into the Google form, which is in my description. Thank you so much, guys, for staying with me till the end. And I really do appreciate, and I wish that I could maybe kind of condense these number of questions that I take each and every week so I can spend the time talking to you guys. Because that's always kind of like my favorite. That's always my favorite, part of the live stream is be able to connect with you guys. The pre-calc exam video, the live stream is going to be next week, which I will kind of give you more details as far as it's not for pre-calculus next week. It's just like how to take how to prepare for an exam and stuff like that. All right. Well, thank you, Michael. Thank you for everything. Well, you're very welcome. I really do appreciate your super chat at the end. And I really appreciate your support. Thank you so much, guys, for staying with me. Thank you again for Michael for the super chat. I am going to go to bed though now because it is late and I got to prepare for tomorrow, another day of teaching. But I'm happy I got my life back, got my planning period, and I'm all set. So hopefully you guys have a great week as well. I'll see you guys later. Cheers.